Happy Monday, everyone. Thanks for tuning in to another Planetarium live stream, and welcome to our 66th Planetarium live stream, supported by MRI Global. Thanks for joining us on this lovely Monday evening. Hope you're all staying safe out there. I know there have been a couple tornado warnings around the Kansas City area, so hopefully not too many of you are having to watch from your basements, but we're going to keep on trucking through this live stream, and if you see me get pulled up into the sky, then I guess that'll be a fitting way to end the streams. But in case you didn't know, my name is Patrick Hess. I'm the Planetarium Specialist at Union Station, and I've been hosting these live streams for the past 11 months, going on a year. In fact, we've got some fun plans for our 1-year anniversary. But thank you all for joining me tonight. Thank you to our returning watchers who have stuck by us over the past 11 months. We've covered so many different topics. I can't believe we've done 66 of these live streams. I think I tallied up the total amount, and we've been streaming for almost 54 hours total. So you could have a marathon and just spend an entire weekend watching all these streams. That just sounds like so much fun, doesn't it? For all of our first-time viewers and watchers, thanks for joining us tonight. As a reminder, this is a live stream, so if you're watching, then please let us know in the comments section. You can say hi to us. You can tell us where you're watching from. It's always fun to see everybody and where they're tuning in from. And then, of course, if you have any questions or comments throughout the stream, please throw those in there, and I will catch them as they come. Already getting a couple people tuning in. One of our longtime watchers, Tammy, says hello from Iowa. Thank you so much for joining us yet again, Tammy. Hope you enjoyed tonight's stream. And Kayla is saying, I'm loving the flag. In the background, I'm assuming you're talking about that backdrop, but we can post a link to a couple different versions of this that I created that you're welcome to download. I'm glad you like it, Kayla. Thanks for that. Definitely a nice spacey backdrop that just reminds you that there's all sorts of cool things out in space, just like there are all sorts of cool people down here on Earth. So, one other reminder, we do post all of our past live streams, so if you're a returning watcher and you want to rewatch any of our streams, or you're a first-time watcher, and you want to check out any of those, or check out any of the past streams you may have missed, and then be sure to head on over to YouTube. And finally, thanks to us getting 100 subscribers a few weeks ago, we now have a real YouTube website. So you can go to youtube.com/KC Planetarium. Once again, youtube.com/KC Planetarium. And you can find our YouTube channel already up to 116 subscribers. And I'm going to vamp for a second. So if you haven't subscribed to our YouTube channel, go over there right now and give us a subscription there, because we have some cool plans for the future of our YouTube channel as well. But for now, we have posted links and recordings of all of our past live streams. So you can check those out. They are organized by our deep dive programs, as well as our star tours and Q&As. Occasionally we do a Q&A live stream where it's all about your questions and answers. So yeah, check those out. And again, youtube.com/KC Planetarium. Thank you to everyone who subscribed to us to make it possible for us to get that. It does sound like a tiny thing, but it's cool that we are legit enough to have a real YouTube channel. So I don't know, I think it's pretty cool. So thank you for all of that. So we are going to jump in. Don't forget, if you have any questions or comments throughout the stream, then please put them in the comment section. I know we have people tuning in throughout the first few minutes here, so let us know where you're watching from, and I love seeing all of your comments as you watch. Now, today's deep dive is going to be all about space technology. Now, we've covered space technology a few times during various live streams in the past, and I'll be talking about some of those examples during the stream today. But I wanted to take a deep dive today and focus on space technology, both in the past and the future. And we're gonna kind of do a list here. Of course, my head is right in the way, but let's actually just hide myself. Hopefully you can still hear me. But so yeah, we're gonna do one of those internet lists that everybody loves reading, and we're gonna look at 10 important past innovations in space technology, so space travel, but also astronomy. And then we're also going to look at some 5 current projects that are sort of in the works that are coming soon, but are definitely happening. And then 5 potential future technologies that are a bit more farther out there in the realm of, I'll say, science fiction for now, although they are based on some real science fact and some principles of physics that we do know about. So that's kind of the outline for our stream today. Nancy, by the way, is watching from Memphis, Tennessee. Thanks for tuning in, Nancy. So glad to see you here, and thanks for commenting and letting us know. And also, Ann is watching from downtown KC. Hello, Ann. Thanks for joining us. That's where I am too, at least in a pocket dimension somewhere in downtown KC. Who knows where, though? So let's dive in and start with this list. And a disclaimer, this list is just my top picks that I think a lot of people would agree were important innovations in technology relating to space. But of course, there's so many others that aren't going to make this list. But these are just some of my favorites, some that I decided to talk about on our stream, and some that there hopefully will be some cool interactives or experiments that we could do with them. I've got a fun plan for that in just a minute. Wendy's watching with a family in Kansas, or family is in Kansas, but Wendy's watching from California. Awesome. Well, thanks for watching, Wendy, and shout outs to your family. Text them to tune in as well. Cynthia is watching from Lawrence. Hello, Cynthia. Thanks for joining us. All right, so let's dive into the first important innovation that is on our list, and that is the Wright Brothers Flyer. So after creating and testing a few different unpowered gliders, the brothers Orville and Wilbur Wright successfully flew their first powered aircraft on December 17th, 1903. And here's a photograph of that famous flight. Now, that flight, it flew a total of 120 feet at a top speed of 6.8 miles per hour, so not super fast, but enough to achieve powered flight for longer than it would have just glided through. There's some archival footage that is available of one of these flights. There is no footage of the first flight, but here's one in 1909 that we can check out. And we'll fast forward. We can see them wheeling out their flyer here. And we will see them test this out. I believe this footage was, 1909. I said that already. A little bit later. All right. So this was a really important technological innovation that related to space flight because it initiated the age of aviation. So obviously to get to space, you have to get into the air first. And so this was an important step along that journey. It's pretty spectacular to think that, this was 1903 that they did their first flight. And then in 1969, we landed a person on the moon. So it's incredible that, less than 70 years after that first flight, we were traveling into space. And so you can see this was a much later flight where they had really honed that technology, and it flew for quite a lot farther. But pretty amazing there. There is also an interactive that you can experiment with, which we can post a link to. But let me pull it up for you here. So this is kind of a fun little activity you can do with your kids at home if you'd like. And this is from the Smithsonian National Air and Space Museum. And so I'm just going to skip some of this. But basically, it walks you through the engineering of what it took to produce this first aircraft. So you do a couple little interactive experiments with different things like the design of wings and the thrust and things like that. And it's a really fun little activity and demonstration that you can do with your kids at home to learn a little bit more about that first historic flight. Not only the technology behind it, but the history, as you can see here, looking at their entire journey. So we can do some flight testing, and we can take off, and we can adjust the elevators and kind of experiment with the angle of the wing and how that affects our flight, and it'll graph it out. So anyway, a little interactive. We can post a link to that in the comments section. So that is the number one past innovation. The number two innovation, I'm actually going to cheat and go a little out of order. I'm going to go back in time even further, because the second thing I want to talk about is a hero's engine. So this was also known as an I can never say this word. Aeolipile is the official technological term, but this was designed by a Greek-Egyptian mathematician named Hero of Alexandria in the 1st century AD. And the reason I'm including this on my list is because this was the first actual demonstration of the principle of energy conversion. So we know today a lot about energy. We know that it can't be created or destroyed, but it can be converted to different types of energy. So, for example, you can have chemical energy stored in, say, fuel, and you can convert that to thermal energy by burning it and converting that to mechanical energy using something like an engine. And so this was the first example of this conversion of energy. And I actually am going to attempt to make my own hero's engine. It's very simple. Well, so let's actually look at his diagram. So basically, this consisted of a chamber with two nozzles pointed in opposite directions on opposite sides with an axle in the middle, and then a fire below to heat the liquid in this chamber, causing it to evaporate and produce steam, and that steam will create thrust as it is expelled out of these nozzles here. And so this was converting the chemical energy in the wood to a thermal energy with fire, and that thermal energy into mechanical energy with this axle contraption. And you can actually create your own hero's engine at home. So all you need is a soda can, and you don't pop the top. What you do is, you might not be able to see it, but you take a safety pin and you poke a tiny hole. Let's see, it might be easier to see this side. There you go. A tiny little hole in one side and in the other, and you're going to drain it completely. So without popping the top, you're going to drain it, but then you're going to put a little bit of water inside of it, so you can hear there's a little bit of water inside of there. And then this is the tricky part, and let me try not to burn my apartment down. I hope people are still watching. Comment if you're still watching. So if I do burn my apartment down, this is worth it in the end. So I have a little stove here that I'm going to precariously balance on my desk. Everything's fine. This is cool. I'm a professional. And then what I'm going to do is I'm going to hold this can above it. And one thing I've also done is I've angled these holes. So I've poked the safety pin in, and then I've kind of bent it downwards on both sides. So the holes are kind of angling outwards. So what I'm going to do is I'm going to heat the water inside this can, which is going to produce steam, and the steam is going to be expelled out of these holes. And then I have it on this little chain that swivels around, and we should be able to produce thrust using this very simple engine. Again, that was invented 2,000 years ago. I'm going to attempt to not burn my beard off as well. Let me just make sure everything is not too wobbly, so it's not just going to fall off. All right. Okay, there we go. We're far enough away from my fire alarm. Okay, this shouldn't take long, but we're going to heat up the liquid inside of this can, which it should start boiling very soon, and it will start producing thrust. Maybe I'll turn it up a little bit more. All right. So this won't take long, folks. Don't you worry. Okay, it's starting to bubble. You might even be able to hear it. It's starting to boil, and then steam's going to come out of those angled holes. And there we go. We have our hero's engine. How do you like that? You might be able to see steam in the camera, but it might be hard to see. It is coming out. And there we go. So I'm going to turn this off here. And we have our hero's engine. Again, you can make that at home. Kids, please have your parents supervise and help you with that experiment if you'd like to do that. And let me put this somewhere that's not going to melt my carpet. All right, great success. I'm very pleased with that. Awesome. All right, so again, this was significant because it proved that we could convert energy, and that's going to be very important when designing rockets. By the way, Craig in the comments says neat related to the hero's engine. Awesome, Craig. Glad you appreciate that. Yeah, try it at home. If anybody wants to try it at home, then feel free to message us later on the Planetarium's Facebook page. Let us know if that experiment worked for you. By the way, if you're watching on the Union Station YouTube channel, go over to the Arvin Gottlieb Planetarium on Facebook or facebook.com/KC Planetarium, and be sure to subscribe to us over there because we have a lot of cool space stuff that we post there that you'll miss if you're only subscribed to Union Station. So as I said, today we know that energy cannot be created or destroyed. Also, this ties in with Newton's third law of motion, which is that for every action, there's an equal and opposite reaction. So as the force, or as the steam is getting pushed out the nozzle, there's force pushing the can in the other direction, and because there are two sort of engines on both sides, the can will rotate. And so this chemical energy is stored in liquid form and converted to thermal energy as it's heated, which is guided through those exhaust nozzles which we call an engine. And this produces kinetic energy in the case of this that can engine or rockets, and that produces thrust. So this principle was applied to rockets all the way back to the 13th century in China, when the first gunpowder-powered rockets were used in warfare. But gunpowder is a solid fuel, and solid fuels are not very efficient. So my number 3 important space innovation was Goddard's rocket. So Robert H. Goddard was an American engineer, physicist, and inventor. And in 1926, he's credited as creating the first liquid-fueled rockets. Now, liquid-fueled rockets have a higher, what we call specific impulse, than solid rockets, which basically just means that they're way more efficient. So you can get a lot more energy from that fuel than you would lose otherwise, that wouldn't be converted to thrust. Also, liquid engines are superior because they can be throttled up and down, so you can increase or decrease their thrust. You can also turn them off and then turn them back on, which is very important for space travel because you don't want to just leave your engine on all the time. There were some rockets, even modern rockets like the space shuttle, that used solid rocket boosters, but the main propulsion were liquid engines. And so the solid rocket boosters, which were the 2 boosters on the side of the space shuttle, when they were used up, they would fall back down to Earth. But the other engines were liquid fuel, and they could be turned off and on. And that's why the space shuttle was reusable. And the solid rocket boosters were much less reusable. So now this first flight of Goddard's rocket, again, was in 1926. And it only flew 41 feet into the air, so not extremely spectacular, but it did prove the concept. And over the next decade, he'd go on to perfect his design, and he would achieve nearly 10,000 feet of lift with one rocket over the next decade, over various launches. So a lot of people say Goddard's rocket tests ushered in the space age. If you want to learn more about rockets and how they work, be sure to check out our rocketry live stream on December 14th, which I'm going to try something different and just show you guys some of these. They're all very nicely organized in order. So this live stream was a lot of fun because I used a program called Kerbal Space Program to actually, we're getting Patrickception here, to design our own rockets. So we learned about how to put a rocket together, and we actually flew a rocket ourselves all the way to space, and then we actually, spoiler alert, even was able to land on the moon with our rocket. So check out that live stream. It's one of our longer live streams, but it was a lot of fun. Let's see. All right. So, moving on to number 4. And we are going a little bit more in order now. And this was the Sputnik launches. Sputnik 1 and 2, which were, of course, I didn't write down the exact dates of these, but Sputnik 1 was launched on October 4th of 1957, and Sputnik 2 was later, obviously, April of 1958. So these were from the Soviet Space Agency, and these, a lot of people say, started the space race between the United States and Soviet Union at the time. But Sputnik 1 here on your left was the first artificial satellite. So this proved that humanity could launch something into a stable orbit, to send something to space and have it actually stay there, and also communicate with it. And then Sputnik 2 proved that life could survive in space. So on Sputnik 2, there was a dog named Laika that was sent into space. Unfortunately, Laika did not survive the complete mission, but did survive the launch, and this did prove that life could exist in space, because at that time, scientists were not sure if humans could even be in space. They weren't sure if our bodies would just explode in space, or our lungs would work in zero gravity. So, unfortunately, there were a lot of creatures that were sent into space to test these things, and many of them did not survive. But they helped pave the way for sending humans to space, of course. By the way, we did a live stream all about artificial satellites, and that was on January 25th, where we talked about all different types and classes of artificial satellites There's a really cool diagram that that's not it, that shows all the different layers of satellites. So check out that live stream. Again, that was on January 25th. That was a fun one as well, all about stuff that humans have sent to space. All right, so I got a couple people chiming into the comments. Lauren says, watching from New Smyrna Beach, Florida. Hello, Lauren. Thanks for tuning in. New Smyrna Beach sounds very lovely right now. I certainly wish I was there. And Eric is also watching from New Smyrna Beach. What a coincidence. Thanks for tuning in, guys. Remember, if you have any questions, anybody watching, be sure to post those in the comment section, or any shout-outs, or just if you want to say hi and ask me how my day is going, then feel free to do that too. All right, so moving on to number 5. How are we doing on time? All right, not too bad. So number 5, I picked the Apollo Computer Guidance System. There are a lot of aspects of the Apollo program that was groundbreaking, obviously. The entire program was a feat of human engineering. And we actually talked about the Apollo program on last week's live stream, which was a VR ride-along, which was very crazy. I was actually inside of virtual reality as I attempted to manually land the lunar lander, the Eagle, on the surface of the moon. So if you want to check out that one out, that was very silly. Again, that is me in virtual reality piloting the Apollo spacecraft. So that was a fun one. So the Apollo program was very cool, and there was a lot of awesome aspects, but I wanted to focus on the computer guidance system specifically. Pictured here, by the way, is Margaret Hamilton, not to be confused with Linda Hamilton, a very different person, but also very cool. Margaret Hamilton here was led the design and coding of all the software responsible for guiding all the Apollo missions to and from the moon. In fact, here you can see she's posted with all the printed out code for the Apollo program, which is incredible. And then you can see her over there, actually inside the spacecraft testing those systems. Up to this point, computers had been the size of entire rooms, but this computer was compacted to a small size of only 70 pounds, which, again, back in the 60s was very significant. And this computer had two main jobs. First, it computed all the necessary course information to the moon, so it calibrated the astronomical instruments that astronauts used in flight. It also used instruments to help navigate using the stars, similar to a sextant, actually. And in fact, we did a live stream last year that I talked about sextants and other nautical navigation tools. And this was a fun live stream because I did this live stream on the beach, on location. So if you want to see a very silly live stream that I produced last year, then check that one out, because that was a lot of fun. I shot that one on location on the lovely sunny beaches of Kansas City. So that was a fun one. Be sure to check that one out for sure. Again, that computer guidance system helped to navigate to the moon using stars and the alignment of bodies like the moon and the sun. And it precisely measured angles from these different objects to recalculate its position on the fly. Humans can pilot aircraft, but aircraft are very complicated in and of themselves. But a spacecraft going to the moon, that was even more complicated, and so a computer system had to be designed. And the computer, its second job was also controlling all the physical components of the spacecraft, over 150 different devices, all the way from propulsion to life support to navigation, so it was very important. You can actually see the original source code. It's available for free on GitHub, which is pretty fun. So you could download the Apollo 11's guidance computer source code. I just love that that's free and publicly available. You can just download it and peruse it if you want. Pretty cool. So check that out if you'd like, and we can post a link to that. Let me make sure we've got a link to it. There we go. So that is my number 5. Let's go over to number 6, which is confusingly Venera 7. I guess I could have organized this better, but this was the next one in historical order. So Venera 7 was the first probe to land softly on another planet. It landed on Venus. It was launched in August of 1970 and arrived at Venus a few months after that. and it was pretty significant. Now, we didn't get any pictures from Venera 7. We got pictures from the later Venera missions, but Venera 7 only lasted 20 minutes before we lost contact with it. But it did send 20 minutes of signals back to Earth, which included surface temperature readings as well as pressure data and physical data from the impact as it touched down. So the reason I chose this is considering Venus has arguably the harshest environment in our entire solar system. By successfully landing a probe there, humanity proved very early in the space age that we could visit anywhere in the solar system. I mean, if we could go to Venus, then we could tackle any other place. And so in the 70s, when we landed on Venus and we got photos back from these later Venera missions, that just really paved the way for us to go anywhere else in the solar system we wanted to, because if we could do Venus, we could do anything else. And we did do a Venus live stream on October 12th, if you want to check that out. Again, if you are tuning in late, you go to youtube.com/kcplanetarium. Once again, that's youtube.com/kcplanetarium. For all of our past live streams, they're organized there in playlists for you. All right, jumping right along to number 7, and these are the Voyager probes. So in 1977, Voyager 1 and 2 were launched, and these were the first deep space probes to explore our solar system, our outer solar system specifically, Jupiter, Saturn, Uranus, and Neptune. And they were also the first probes to actually leave the solar system. Today they're in interstellar space, and we are actually starting to learn about what space is like beyond the edge of our solar system. They also carried messages from humanity to the stars in the form of the Golden Record, which are included on both Voyager probes. These records include music from Earth as well as pictures and messages. And we actually did a whole live stream about the Voyager Golden Record on May 13th, all the way back last year, so check that one out if you want to learn more about what's on that Golden Record. And we also, oh, that's not the one I wanted. We have talked about this program before. This is NASA's EYES, which is a free program you can download or access on their website. And they have a number of modules all about different missions, and they do have a Voyager deep dive as well. Oh, here we go. We're loading it now. Ooh, there's my computer taking off. All right, so this is a really cool 3D program that is totally free. You can download that lets you explore the solar system and many of the missions from NASA. And here we can see Voyager at its current spot, very far away from our solar system. But this has information about the Voyager missions, their interstellar missions, and then we can even go back in time and see their earlier missions as they as they were closer to the solar system. And if I zoom way out here, we can kind of see the scale at which these probes are. So they're very far away, and they've recently actually crossed that boundary that we considered to be the edge of our solar system. So again, there are the Voyager probes, and we may be able to see on here. Yep, there's the Golden Record. How do you like that? It's actually on our image here, and yeah, ooh, that's better. Yeah, so a little bit brighter. The record's actually right there on the side of the spacecraft. So you can explore all about many of the missions from NASA using this NASA EYES program. All right, so again, that was the Voyager space probes, my number 7 pick for important space innovations, because they are helping us not only to learn about the outer reaches beyond our solar system, but they also carry humanity's message to the stars. So the next choice, my number 8 for past space innovations. Actually, before I do that, I do have a question here just popped up. Wendy asks, do you have any live streams specifically about Mars or Pluto? I'll have to look, seeing as my kiddo has lots of questions. My 3-year-old is the space expert in our house. Well, that's so awesome, Wendy. And if your 3-year-old is watching, then shout outs to you. I'm glad that they love space and want to learn more about that. And Wendy, we do of course absolutely have live streams about both Mars and Pluto. I'd encourage you to check out our August 10th live stream, which was all about Mars. And that was last year, August 10th, 2020. And then we did a live stream about Pluto, the first live stream of this year, and that was on January 4th. So live streams for both of those, again, August 10th and January 4th. And go over to youtube.com/kcplanetarium, and you can find all of our past streams. So I hope you enjoy those, Wendy, and hope your 3-year-old does as well. Patience says, You guys seem safe, is all good. I think maybe in relation to the tornado warnings that were issued. Knock on wood, I have not gotten any sirens here in downtown Kansas City, but I hope everybody else is safe from around the metro area. All right, so my number 8 choice, as I was getting ready to say, is adaptive optics. Now, this is a bit of a change of pace because this is not a space traveling technology. This is a astronomy technology. And the reason I chose this is because, well, I think it's very cool, but it's very important for ground-based observing. Now, we have sent telescopes to space, like the Hubble Space Telescope and the upcoming James Webb Space Telescope, which I may mention later. But it's very expensive and very hard, and it takes a long time between these missions to send telescopes to space, and if something goes wrong, it's hard to fix those telescopes. So astronomers prefer to observe here on Earth if they can, just because it's cheaper and easier to maintain. But the difficulty is, here on Earth, our atmosphere gets in the way of our observing of space. And that's why the stars twinkle, if you've ever seen stars twinkle. Our atmosphere causes the light from stars to be distorted and wobble. And this means that when we look at distant objects like, I believe, Neptune here, they become very fuzzy in our ground-based telescopes, unless we use something called adaptive optics. Now, this was developed in the 1990s, and basically what it does is it records the wobble of the atmosphere. So you'll sometimes see these pictures of observatories sending lasers out into space, and we're not trying to blow up any planets. What we're doing is we are actually sending a laser up through the atmosphere, and then a camera looks at that laser. And because we know the exact type of light the laser is beaming, and we can measure the exact pattern of that wobble that the laser is seeing, then we can use sort of a flexible mirror right here, which is labeled as the wavefront corrector, that basically we can use motors to essentially unwobble the image. So we can wobble the mirror in a pattern that complements the wobble of the stars, and then basically we can remove the wobble. And so you can see here an actual photograph comparing what it looks like without adaptive optics to a picture taken with adaptive optics. So this is really cool technology that allows us to do some pretty astounding ground-based observations that we wouldn't have been able to do without before without actually going into space with our telescopes. So that's why I picked adaptive optics as my number 8, and we're going to move on before I try to say it again and stumble over my words again. All right, so my number 9 choice is the International Space Station. Now, this $100 billion piece of engineering, obviously, in and of itself, is an amazing feat of human ingenuity. But that's not the reason why I picked it. The reason why I picked it is really what it represents. So the International Space Station, which has been in space for over 20 years now, is proof of international cooperation. So there are many different countries that have collaborated to build this space station, many different modules coming from around the world. And, you know, even here in the 21st century, there are a lot of disagreements between different peoples and different nations down on Earth. But I think what the International Space Station represents is that humans can cooperate if they want, and they can achieve pretty amazing things. This also proves our long-term habitability in space. We have had humans in space consistently for 20 years. And they've lived aboard the International Space Station. So this is just proof that, you know, we can go to space and we can cooperate. And if we cooperate, we can do some pretty amazing things. And we actually did a live stream about the International Space Station back in October. And that was, let's see, on October 20th. Just right here, and I wanted to point this out because I built an International Space Station out of Legos, so that was pretty fun. We actually put it together in order as it was being built in real life using this cool Lego set, so that's a fun live stream with a bit of a different type of demonstration if you want to check that out, if there are any Lego fans in the audience as well, of course. All right, so number 10, my 10th past space innovation is reusable rockets. So now, first of all, I want to acknowledge that the Space Shuttle sort of did this. The Space Shuttle operated from the late 80s to 2011, and the Space Shuttle was designed to be reusable, but it wasn't extremely reusable. It was extremely expensive every time it landed. We had to almost take it apart completely and put it back together for it to be safely reused. So it really wasn't truly reusable. But the Falcon 9 spacecraft pictured here from SpaceX is really the first truly reusable rocket. In fact, yesterday they set a record. They reused a rocket for the 9th time. So These rockets are designed to go into space and come all the way back down and land softly on the ground, or on a, in this case, you see here it's a boat on the ocean, actually. This allows us to reuse them with very little, or they're designed to be reused with very little rebuilding necessary. And they're going for 10 on this rocket, and that would be an incredible feat. And the idea of having rockets being reusable is they're way cheaper. And when rockets are way cheaper, it's cheaper to send stuff into space. And when it's cheaper to send stuff into space, we can send more stuff into space and more people into space. We've sent humans aboard the Falcon 9 rocket last summer, in fact. We did 2 missions last year, 1 test mission and then 1 official mission to the International Space Station aboard the Crew Dragon capsule. By the way, we did a live stream to talk about that, which I'm attempting to look up here. Let's pull this back up. Let's see. Would have been around May. Believe. Yeah, so it was it's actually one of our Star Tour streams, but I also talked about it as a deep dive into this first launch of American astronauts aboard a spacecraft. The first time that's happened since 2011. Last year we sent American astronauts aboard our own American spacecraft, the Falcon 9. Up to that point we had been hitching rides aboard the Russian spacecraft, so we could see them boarding the spacecraft here, and they did reach space successfully. So again, that was on June 1st, where we talked about that mission. So yeah, so that's the most recent, my pick for most recent important innovation, because now that we're able to reuse rockets efficiently like this, then hopefully we'll be able to send even more things into space, including people, and this will just hopefully usher in a new age of space travel that will send even more people to space than ever before. So that's all for past innovations, and we are already coming close towards the end of our stream, so don't forget that if you have any questions or comments, put those in the comments section below, and I will answer those as they come. But we are going to kind of blast through the next 2 lists a little bit quickly, because I want to talk about some current projects as well as some future possibilities. So the first one I want to talk about is the James Webb Space Telescope. Jordan, if you're watching, I hope you're happy that I talked about this. Now, a lot of people say that the James Webb Space Telescope is the successor to the Hubble Space Telescope. That's not entirely true. It is the most significant space telescope that we've sent into space since Hubble, but it's designed to do very different things. For example, it's really not designed to take cool photos like the Hubble does. It has most of its instruments capture light in non-visible wavelengths. The exciting thing about it, though, is that the optics aboard this telescope will be able to look very, 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 very far away, and in turn look way back in time. So the farther away we look, so when we look at objects that are very distant, we're also looking back in time, because the light from them has taken so long to reach us that we're looking at those objects millions, if not billions of years in the past. And the James Webb Space Telescope has instruments to peer even further back into the dawn of our universe, which will hopefully give us insights into how our universe was created and what really led to something like the Big Bang, if that is really how it started. By the way, we did a live stream all about space telescopes back on October 5th, so check out that live stream to learn more about James Webb. Number 2 is the Juno mission. This is an ongoing mission to the king of the planets, Jupiter. And this is sort of the spiritual successor to Saturn's Cassini spacecraft, which orbited Saturn for over a decade. The Juno mission began in 2016, and it's been exploring ever since. It was actually scheduled to end its mission, but like Cassini, it was extended quite a ways. In fact, right now, Juno is scheduled to go all the way till 2025. And it will likely be directed now to explore some of Jupiter's moons in greater detail, just like how Cassini explored Saturn's moons. And we can look at... oh, by the way, I didn't even realize this. So this actually... So backtrack here a little bit. You can look at our heliosphere, which is sort of the edge of our solar system. That shows us Voyager is actually there on the edge of our solar system. And then you can even take a tour following Voyager's journey. So there's a lot of interactions here on NASA's EYES program. But I would like to go back home and check out Juno. Let's go over here to Jupiter, and hopefully we'll be able to find Juno. Where are you, Juno? All right, let's get out here. Tourism features, Juno. All right, so there are a lot of different probes you can explore with NASA's eyes. It's a really awesome program. I'd highly encourage you to check it out. And it's loading the Juno mission. So Juno is exploring Jupiter. It's taken some pretty incredible photographs. And there it is. So Juno is somewhere near Jupiter, or a bit far away from Jupiter right now. So let's explore its mission a little bit. So currently it's pretty far away. It's in a very elliptical orbit right now. It's going very far away from Jupiter and then very close over and over again. There you can see its orbit. So it's doing close flybys to get really close photographs, like the photograph we saw a moment ago of the, I believe, south pole of Jupiter. So yeah, so we can explore Juno's mission on NASA's eyes. We don't have time to do all of that exploration today, but just wanted to point out that you can learn a lot about Juno's mission, or just follow along, because the next 5 years we should get some really awesome science from it. We did a live stream all about Jupiter, by the way, on June 29th, so check that one out from last year. All right, my number 3 pick for current missions in development is extraterrestrial aircraft. So this is a photograph of the Ingenuity helicopter that is aboard the Perseverance rover. By the way, Perseverance landed recently, last month, almost exactly a month ago, in fact, on February 18th. We did a live stream that day covering the Mars rover landing, so check that out if you want to learn more about that exciting landing. But this helicopter, which right now they are testing out and potentially will be doing its flight missions in the next few months, so stay tuned for that, is going to be the first aircraft aboard or that will fly in the air of an extraterrestrial planet. And so this is an important step, because so far all the rovers we've sent have been on wheels, and there are a lot of limitations to wheeled travel. If you've ever seen photographs of Curiosity's wheels, which is the rover that was sent in 2012, its wheels have been really dinged up from all the rocks and stuff, and we can't really fix those wheels until we send people to Mars. But helicopters and aircraft are able to explore much greater distances with a theoretical much lower damage, or much less damage over time, as they can just fly over rocky terrain. The Ingenuity helicopter doesn't actually have any scientific instruments aboard it. It's really just a proof of concept that it is possible to fly, but we'll be taking pictures and hopefully some video of its flight from the Perseverance rover as it takes off. So they did test all of its systems, I know, and it is still functioning. There are also activities here. By the way, this website is all about the Mars exploration program. And if you want to explore that, you can go to mars.nasa.gov, and that has all about the Mars mission, but it also has some downloads you can do at home, so you can make your own paper helicopter, and you can also do a video game where you can actually code the Mars helicopter, so that's pretty cool. A little coding for you. So that's exciting, and that should be launching pretty soon. The other current mission is, or the current development in space technology is global space transit. Now, this you might not have heard about, but you have heard about the Starship if you've watched our live streams. So Starship is SpaceX's next rocket platform. The Falcon 9 is what it's currently flying, and Starship is what it's currently testing. We've covered a few of its tests. Its 10th test was a few weeks ago, and it did successfully land, although it did explode after landing, which we prefer rockets do not do. The 11th test will be coming up soon, but Starship is designed to go to space, of course, potentially go to the moon and Mars, but it's also designed for a potential earthly use, and that would be actually to use as sort of public transportation. So there is a video that SpaceX produced, which I'm not going to play just because we might get copyright striked, but I'll show you stills from it. So their idea is that using this type of rocket, once it's safe and doesn't explode after landing, potentially we could send, well, not send, we could have regular civilians buy tickets aboard this rocket, just like you would buy tickets to, or for an airplane flight. But instead of flights that last hours, if not dozens of hours, to get around the world. These flights would go into space and then land softly on the ground in minutes. So this rocket, so this is a conceptual rendering of the future Starship version that would actually take passengers into space. So it would theoretically launch from a barge out on the water. So you would take a boat to get to it. This rocket would go into space. So aboard this transportation, you would actually go into space, which would be pretty fun. And then it would actually fly through space back down to the ground. And that flight from New York to Shanghai would be 40 minutes. So think about that. So instead of taking half a day in the air to fly there, you could almost commute aboard this spaceship to a job halfway around the world. And in their video, they have other examples: Hong Kong to Singapore in 22 minutes, London to New York in 29 minutes. So this is, I put this in my current missions or current space innovation section because we are testing these rockets that will that would be performing these flights. There are still a lot of regulations to go through for this to be approved for passenger travel, but I have no doubt in my mind that we are heading in this direction someday in the future. And the last thing that's currently in development are solar sails. This is kind of cool. The first test was a mission called Icaros in 2010. And the idea is for a highly efficient spacecraft propulsion system that just uses sunlight. Basically, it uses radiation pressure exerted by the sunlight on large mirror surfaces. So the actual photons essentially would be pushing a spacecraft. So this would require extremely little energy sent up in that spacecraft. And you could theoretically accelerate to great velocities using this type of technology. There have been a couple other missions that have tested out this technology, but so far it's at a very small scale. But this is a potential new propulsion system that we could see astronauts or deep space exploration missions using in the near future over the next few decades. So real quick, I wanted to go over some potential future technologies, and this will be wrapping up our live stream tonight, so be sure to put any of your final comments or questions in the comment section. But these are just more of the far out there science fiction ideas that are based on some real physical properties, but we are very far away from creating technologically. And the first one is a space elevator. I actually talked about these a little while ago on one of my Hollywood live streams, I believe. Yep, that was our last Hollywood live stream. We've done 2 of them. The most recent was on January 18th, where we looked at a bunch of movies and how accurate they were in terms of astronomy. And then July 20th, we did another movie astronomy stream last year. So check that one out if you're into movies and space exploration. So space elevators here, essentially, here's a better visualization. Essentially, what you have is you have an object placed in a specific orbital plane far away from the Earth that's orbiting at the same speed that the Earth is. And then you have a tether connecting all the way from the ground up to this orbital station. And the idea, which is this has actually been proposed all the way back in the 1800s. Relative to rockets, this elevator would be far cheaper and faster to get cargo and people off the Earth if you wanted to just get into Earth orbit. But there's a lot of challenges, and this is why we have not even started designing these types of projects. The strength of this cable, because it would be very heavy and it would have to support not only its own weight, but that weight distributed over tens of thousands of miles. It requires a material so strong that it frankly doesn't exist yet. There are physicists and engineers testing out different materials like carbon nanotubes or recently created diamond nanothreads that potentially could be strong enough to support this type of weight. And there's even an organization called the International Space Elevator Consortium that is pushing for this technology, but it's still very far away in the realm of science fiction. Number 2 is a Mars colony. So, of course, someday we want to send astronauts to Mars, but we'll hopefully take them back to Earth after they land on Mars. And the reason is because it's very dangerous to live on Mars for an extended period of time. Unlike the Earth, Mars does not have a molten core, which means that Mars does not have a strong magnetic field. Now, the Earth's magnetic field protects us from harmful solar radiation. On Mars, there is no magnetic field, so you are not protected from solar radiation, and if you were on Mars for an extended period of time, you would absorb a lethal dose of radiation that would cause serious health problems. So the challenge, not only getting astronauts to Mars, is to have them live on Mars for an extended period of time safely. There are a couple different ideas and ways that we might protect ourselves from solar radiation. Water actually is a great insulator from radiation. So if we lined the outside of our colonies, the walls themselves, with water, that could potentially protect us in a way. Or we could design our habitats below the ground, and that could be somewhat protected from radiation as well. Now, currently, the Artemis program from NASA plans to land astronauts back on the moon in 2024. And on their plans, at least on paper right now, this program would also send astronauts to Mars sometime in the future, but who knows how long in the future that would be. By the way, the next test of the Space Launch System, that is NASA's mission to send people back to the moon, is going to be in mid-2021. Actually, they're testing the engines this Thursday, so hopefully some exciting rocket tests happening this year that could potentially lead us on the path towards a Mars colony someday in the future. Number 3 is a Europa or Enceladus explorer. Now, I've mentioned Europa and Enceladus in the past. In fact, I did my top 10 moons live stream on November 14th last year, and September 14th. And spoiler alert, Enceladus is my favorite moon in the solar system. But the idea is that both Europa and Enceladus are ice worlds. They're covered in a thick sheet of ice, but below that ice, we know, is a liquid ocean of water. And on Enceladus, at least, we know that that ocean is potentially warm water, since we have detected elements in the water of these oceans that could be from hydrothermal vents, which are warm vents here on Earth. So we think there could be warm oceans of liquid water below the ice of these moons. And so the idea that some scientists are proposing is we could send a lander to these moons and potentially drill through that ice and actually send a submarine to explore the waters of these moons. The exciting thing about this is that both Enceladus and Europa are the top candidates for places here in our solar system that could already have life. A lot of scientists think that early life may have evolved close to these hydrothermal vents at the bottom of Earth's oceans, and so it's plausible that there could be very simple life currently living in these moons. And so someday, hopefully, we'll send missions to Europa or Enceladus. There's a mission in development to go to Europa right now called the Europa Clipper mission, set for launch in 2024, and it could lay the groundwork for this future mission. And number 4 is megastructures, like a Dyson sphere, or a rotating Earth gravity habitat like that. And the idea is to simulate an Earth-like gravity to make it comfortable to live in space, or in the case of this sphere here, to actually harness the power of things like the sun. Now, similar to a space elevator, this will require materials so strong they have not been invented yet to actually create an object this gigantic at the scale of entire planets or solar systems. But this has been present in science fiction for decades. And so, potentially someday we could be living on one of these rotating space colonies, but that is probably decades, if not centuries, away. And the last thing on my list is the warp drive, or Alcubierre drive, named after one of the physicists who has created this theoretical type of warp drive. Now, to achieve speeds close to or faster than light, it's basically not possible with our current understandings of physics. You would need nearly infinite amounts of energy to reach these speeds. So some scientists have proposed that, well, maybe we don't actually want to go fast. Maybe what we want to do is we want to bend space around us to propel us. So the way an Alcubierre drive would theoretically work is that it would actually bend the fabric of space-time, creating areas of high and low gravity in front of and behind it to actually use the fabric of space to push itself. Now, this theoretically could work based on our current understandings of physics, but it would require types of energy that we don't know exist. It would require it would require mass that had, it would require objects that had negative mass. And right now, our current understandings of physics don't fully explain how that could be possible. There are some quantum theories that could potentially explain the existence of something that has negative mass, but right now, that's squarely in the realm of science fiction. But it is still cool that there are some scientists out there thinking about these distant futures that maybe we would have the technology to actually invent a warp drive that could allow us to travel theoretically faster than light, which would allow us to explore beyond our solar system in the span of human lifespans. So that is my list of past, present, and future space technologies, folks. So we're going to be wrapping up this stream here, and we did have a couple comments and questions here. Craig, commenting about Mars Ingenuity, said, will it fly and land to recharge or just have one flight? So the Ingenuity aircraft, Craig, is designed for, I think, up to 4 flights. It does have a battery and solar cells on it. But they are, and scientists often sort of underpromise and hopefully overdeliver, just like the Juno mission, as I mentioned before, was set to end this year, but it was extended many years beyond. So right now they're only planning, I believe, 4 test flights for Ingenuity, but they could definitely extend that into the future. But we will see. It is designed to recharge, though. But I believe just the way it's designed and the amount of power its batteries can hold, I don't think it can fly for that long. It's also very cold on Mars, and the electronics are insulated, but most of the energy that is captured by those solar cells is actually used to just keep the electronics warm. So there's a lot of wear and tear that happens too. But who knows, Craig? Hopefully things go well with its designed mission, and they can extend that mission further. And then Patience asks about a tie-down like scuba diving. And I'm sorry, Patience, I didn't see exactly when you commented that, so not sure exactly in reference to what, but it could have been a couple things like the space elevator, for example. That tether, you could think of it like scuba diving, having a tether attached to the ground, going all the way up into space, just like for a scuba diver. And in terms of like sending oxygen up into space, that may not be the most efficient way. It may make more sense to just carry the oxygen in tanks up there. So hopefully that answered your question, Patience. I'm not sure if that's exactly what you were asking about, but maybe I'll find out here in a second. Comment was 6 minutes ago, so potentially... if either it was about the space elevator or maybe the Europa and Enceladus missions, those could have tethers to their space. Nope. So it was about the space elevator. All right, great, awesome. Sorry, I'm on a bit of a delay from everybody. So thank you all for your patience. All right, so we are going to wrap up the stream, folks. So thank you all so much. Hope you enjoyed this deep dive into a few different space technologies. Don't forget, if you haven't subscribed to the Planetarium's Facebook page, go to facebook.com/kcplanetarium and give us a like and subscribe over there to catch up on all of your space news as it comes out. And go over to youtube.com/kcplanetarium and subscribe to us there for many other space videos, including all of our past live streams, which are available there. Thank you all so much for joining us today. Hope you enjoyed this stream. Let me give you a little teaser of some things coming up. Next week, we are going to do a What's Up Star Tour. We haven't done a Star Tour for quite a while, since December, in fact, and spring is around the corner, so we're going to do a Spring Star Tour next Monday. We're going to look at what's up in our night sky this coming season, so don't miss that. And then stay tuned for announcements about the future of our live streams, because we do have plans coming soon to make some adjustments to our live streams moving forwards. But don't worry, we will be keeping these going. But we do have announcements coming about the future of our streams and future programs at the Planetarium, which is a perfect segue. Don't forget, we are open at the Gottlieb Planetarium. Please come visit us if you feel comfortable. You can see any of our live star tours there, which are hosted by myself or one of our other amazing educators. Or you can watch one of our other space documentaries. We have a great new slate of shows coming this week. Our Mars 1001 Mission to Mars show is coming back. And we're also doing a show about dark matter called Phantom of the Universe. So check those out. And all of our kid favorite shows are coming back as well. Big Bird's Adventure, of course, Sesame Street Show, and Magic Treehouse, based on the kids' book series. So a lot of great options for the whole family. You can reserve tickets online in advance at unionstation.org. We encourage you to do that. Our laser shows are available as well. We have April lasers coming the first weekend of April, and May as well. And then we'll be announcing future schedules for those laser shows coming up as well. So thank you all so much for supporting us, whether you're coming to the planetarium or whether you're watching these live streams or subscribing to us. It's a great help and it keeps us going, and it's been a great support over the past year. So thank you all so much for sticking with us. And one last comment from Eric saying, great show. Thank you so much, Eric, for watching this stream and so many others. I have been your Planetarium Specialist, Patrick Hess. Thank you for joining me tonight for this Monday night stream. And thank you to our supporting sponsor, MRI Global, for keeping these live streams going and supporting the other programs at Union Station. But I am going to go ahead and sign off. So you all have a wonderful evening. We'll see you here back next week at 6 p.m. for our Spring Star Tour. Patience says, a round of applause. Thank you so much, Patience. See you all next week. Bye, everyone.